Welcome to the Academic Skills Unit's Guide to Integers. Positive numbers and negative numbers are directed numbers, as they have both size and direction. As seen here on the number line, numbers get bigger as they move to the right and smaller as they move to the left. All of the counting numbers, both negative and positive, are called integers. All integers can be added and subtracted, whether all negative, all positive, or a mixture of both. Watch this clip for some tips on how to work with addition and subtraction of integers.
Let's have some practice adding and subtracting negative numbers. So the first example I want to look at is 2 minus 3. So right now I'm just subtracting a positive number from another positive number, but you might already see that I'm subtracting a larger number from a smaller number, so I'm probably, or I will definitely end up with a negative number. But let's just think about this a little bit, and I'm going to do it with the number line. So there's my number line right over there. Now this is 0, this is 1, this is 2, this is -1, this is -2. We could view this as starting at 2, so this is 2 right over here, and then we're going to subtract 3 from that 2. So we're going to move 3 to the left on the number line. So we're going to move 3 to the left. 1, 2, 3. And that gets us to -1. This is equal to -1. Now let's mix it up a little bit more. Let's imagine what would happen if we had -2. -2 minus 3. So this was +2 minus 3. Now let's think about -2 minus 3. So once again, let's draw our number line. And I'll put 0 over here. So this is 0, this is 1, this is -1, -2, -3, -4, -5, -6, and I could keep going. But we're starting at -2, and then we're subtracting 3 again. So once again, we're going to move 3 to the left of -2. So we go 1, 2, 3. We end up at -5. So this is -5. So notice in both situations, we subtracted 3. We moved 3 to the left on the number line. It's just here we started 2 to the right of 0. Here we started 2 to the left. 2 to the left of 0. This is -2. Let's do another example with these same numbers. Let's imagine -2 plus 2, or sorry, plus 3. And I encourage you to pause this video and try to think about this on your own. So we draw the number line again. I could draw a straighter number line than that. So draw the number line again. And let's say that this is -2, -1, 0, 1, and 2 again. We're starting at -2. We're starting 2 to the left of 0. So we're starting at -2, and we're going to add 3. So we're going to go 3 to the right now. 1, 2, 3. And we end up at +1. Now let's think about 2, so +2, and we're going to subtract a -3. So we're going to subtract -3. In other videos, we've already talked about this. In fact, there's a video explaining why this actually makes sense. But when you subtract a negative, this is the same thing as adding the positive. So 2 minus -3 is the exact same thing as 2 plus +3. These two statements are equivalent, and this is just boils down to this right over here is just going to be 5. Now let's mix it up a little bit more. Let's imagine -2. Let's imagine -2 minus -3. Minus -3. Now this might seem really intimidating. I have all of these negatives in place here, but you just have to remember, subtracting a negative like this is going to get you a positive. So this is the exact same thing as -2 plus 3. And -2 plus 3, we've already seen it right over here. You start at -2. You start 2 to the left of 0. And then we're going to go 3 to the right. We're adding 3. 1, 2, 3.
Pause the video to try some of these problems. Multiplication is also possible with positive and negative integers. The following clip explains how to complete these calculations.
we know that if we were to multiply 2 times 3, that would give us positive 6. And since we're going to start thinking about negative numbers in this video, one way to think about it is I had a positive number times another positive number, and that gave me a positive number. So if I have a positive times a positive, that will give me a positive number. Now let's mix it up a little bit. Introduce some negative numbers. So what happens if I had negative 2 times 3? Negative 2 times 3. Well, one way to think about it, and we'll talk more about the intuition in this video and in future videos, is, well, you could view this as negative 2 repeatedly added 3 times. So this could be negative 2 plus negative 2 plus negative 2, not negative 6, plus a negative 2, which would be equal to, well, negative 2 plus negative 2 is negative 4, plus another negative 2 is negative 6. So this would be equal to negative 6. Or another way to think about it is, if I had 2 times 3, I would get 6. But because one of these two numbers is negative, then my product is going to be negative. So if I multiply a negative times a positive, I am going to get a negative. Now what if we swap the order in which we multiply? So if we were to multiply 3 times negative 2. Well, it shouldn't matter. The order in which we multiply things don't change, or it shouldn't change the product. Whether we multiply 2 times 3, we'll get 6, or if we get multiplied 3 times 2, we'll get 6. And so we should have the same property here. 3 times negative 2 should give us the same result. It's going to be equal to negative 6. And once again, we say 3 times 2 would be 6. One of these two numbers is negative, and so our product is going to be negative. So we could write a positive times a negative is also going to be a negative. And both of these are just the same thing with the order in which we're multiplying switched around. But this is one of the two numbers are negative, exactly one. So one negative, one positive. One positive number is being multiplied. Then you will get a negative product. Now let's think about the third circumstance, when both of the numbers are negative. So if I were to multiply, I'll just switch colors for fun here. If I were to multiply negative 2 times negative 3, and this might be the least intuitive for you of all, and here I'm just going to introduce you to the rule, and in future videos we'll explore why this is and why this makes mathematics more all fit together. But this is going to be, you say, well, 2 times 3 would be 6. And I have a negative times a negative. And one way you can think about it is that the negatives cancel out. And so you will actually end up with a positive 6. I actually don't have to write a positive here, but I'll write it here just to re-emphasize. This right over here is a positive 6. So we have another rule of thumb here. If I have a negative times a negative, that they're actually the negatives are going to cancel out, and that's going to give me a positive number. Now with these out of the way, let's just do a bunch of examples, and I encourage you to try them out before I do them. Pause the video, try them out, and see if you get the same answer. So let's try negative 1 times negative 1. Well, 1 times 1 would be 1, and we have a negative times a negative. They cancel out. Negative times a negative give me a positive, so this is going to be positive 1. I could just write 1, or I could literally write a plus sign there to emphasize that this is a positive 1. What happens if I did negative 1 times 0? Now this might say, wait, this doesn't really fit into any of these circumstances. 0 is neither positive nor negative. And here you just have to remember anything times 0 is going to be 0. So negative 1 times 0 is going to be 0. Or I could have said 0 times negative 783. That is also going to be 0. Now what about let me do some interesting ones. What about, I'll pick a new color, 12 times negative 4? Well, once again, 12 times positive 4 would be 48. And we're in the circumstance where one of these two numbers right over here is negative. This one right over here. If exactly one of the two numbers is negative, then the product is going to be negative. We are in this circumstance. Right over here. We have one negative, so the product is negative. You can imagine this as repeatedly adding negative 4 12 times. And so you would get to negative 48. Let's do another one. What is 7 times 3? Well, this is a bit of a trick. There are no negative numbers here. This is just going to be 7 times 3, positive 7 times positive 3. The first circumstance, which you already knew how to do before this video. This would just be equal to 21. Let's do one more. So if I were to say negative 5 times negative 10. Well, once again, negative times a negative, the negatives cancel out. That you're just left with a positive product. So it's going to be 5 times 10. It's going to be 50. The negative and the negative cancel out. Your product is going to be positive. That's this situation right over there.
Pause the video to try some of these problems. Similarly, all integers can be divided. They are treated in a similar way to multiplication, as shown in the following clip.
Now that we know a little bit about multiplying positive and negative numbers, let's think about how we can divide them. And what you'll see is that it's actually a very similar methodology. That if both are positive, you'll get a positive answer. If one is negative, but not both, you're going to get a negative answer. And if both are negative, they will cancel out and you will get a positive answer. But let's apply it. And I encourage you, pause this video and try these out yourself and then see if you get the same answer that I'm going to get. So 8 divided by negative 2. So if I just had 8 divided by 2, that would be a positive 4. But since exactly one of these two numbers are negative, this one right over here, the answer is going to be negative. So 8 divided by negative 2 is negative 4. Now negative 16 divided by positive 4. We have to be very careful here. If I just had positive 16 divided by positive 4, that would just be 4. But because one of these two numbers is negative, and exactly one of these two numbers is negative, then I'm going to get a negative answer. Now, I have negative 30 divided by negative 5. If I just had 30 divided by 5, that would be positive 6. And because I have a negative divided by a negative, the negatives cancel out, and so my answer will still be positive 6. And I could even write a positive out here. I don't have to, but this is a positive 6. A negative divided by a negative, just like a negative times a negative, you're going to get a positive answer. 18 divided by 2, and this is a little bit of a trick question. This is what you knew how to do before we even talked about negative numbers. This is a positive divided by a positive, which is going to be a positive. So that is going to be equal to positive 9. Now we start doing some interesting things. Here's this kind of a compound problem. You have some multiplication and some division going on. And so first, right over here, the way this is written, we're going to want to multiply the numerator out. And if you're not familiar with this little dot symbol, it's just another way of writing multiplication. I could have written this little x thing over here. And what you're going to see is in algebra, the dot becomes much more common because the x gets used for other things. Or there's the times symbol, people don't want to confuse it with the letter x, which gets used a lot in algebra. And so that's why they use the dot very often. So this just says negative 7 times 3 in the numerator, and then we're going to take that product and divide it by negative 1. So in the numerator, negative 7 times 3, positive 7 times 3 would be 21. But since exactly one of these two are negative, this is going to be negative 21. And it's going to be negative 21 over negative 1. And so negative 21 divided by negative 1, negative divided by a negative is going to be a positive. So this is just going to be positive 21. Let me write all these things down. So if I were to if I have a positive divided by a negative, that's going to give me a negative. If I have a negative divided by a positive, that's also going to give me a negative. If I have a negative divided by a negative, that's going to give me a positive. And if I have, obviously, a positive divided by a positive, that's also going to give me a positive. Now let's do this last one over here. This actually is all multiplication, but it's interesting because we're multiplying three things, which we haven't done yet. And we could just go from left to right over here. And we could first think about negative 2 times negative 7. Negative 2 times negative 7, they are both negative. The negatives cancel out. So this will give us, this part right over here, will give us positive 14. And so we're going to multiply the positive 14 times this negative 1. Times negative 1. Now we have a positive times a negative. Exactly one of them is negative. So this is going to give me a negative answer. It's going to give me negative 14. Now let me give you a couple of more, I guess we could call these trick problems. What would happen if I had 0 divided by -5? Well, this is 0 negative fifths, or 0 divided by anything that's non-zero is just going to be equal to 0. What if we were to do the other way around? What happens if we said -5 divided by 0? Well, we don't know what happens when you divide things by 0. We haven't defined that. There's arguments for multiple ways to conceptualize this, so we traditionally just say that this is undefined. We haven't defined what happens when something is divided by 0. And similarly, even if we had 0 divided by 0, this is still undefined.
Pause the video to try some of these problems. As a handy reminder for what happens when multiplying and dividing integers, think of these examples with friends, positive numbers, and enemies, negative numbers. When multiplying or dividing two positive numbers, you'll always get a positive answer. Think of this as the case that a friend of your friend must be your friend. Likewise, two negative numbers will always give you a positive answer. Think of this where an enemy of your enemy must also be your friend. This idea continues with unlike signs, where a friend of your enemy must be your enemy, and an enemy of your friend must also be an enemy. It may be quite philosophical, but a good way to remember like signs give a positive answer, and unlike signs give a negative answer when dealing with multiplication and division of integers. Feel free to use the summary sheet to take some notes about using integers. It would be great for revision, and also if you'd like to take the quiz in this module. It will allow you to check your understanding of dealing with integers using all major operations: addition, subtraction, multiplication, and division.